Scatter plot. A scatter plot is a type of graph which is used to represent the relationship between two variables in a data set. So whenever you are trying to plot a scatter plot or a scatter graph, we need to have two different variables, right? And then we plot a graph against these two variables to see how these two variables are interacting with each other, or how these two variables are basically correlated or related with each other, right? It displays data points on a two-dimensional plane with the independent variable plotted on the x-axis and the dependent variable on the y-axis. What does it means essentially is that on the y-axis you will have something which is dependent on the x-axis, right? So ultimately you will have to have two data variables. One is the x-axis variable, and one is the y-axis variable. And the y-axis variable is an independent variable, which essentially means that x-axis variable is dependent on certain formulas, certain calculations using the data values from the y-axis. So that is how your scatter plot or a correlation between x and y is basically plotted as a part of the scatter plot, right? Now the question essentially here is, so here we have taken a data point and I've used the same data point as in serial numbers 1, 2, 3, and there are 20 different data points for a particular process, and against each of the data points we have data values, right? So you can see that the data point 1 has a value of 61, data point 2 has a value of 65, and so on and so forth. We have 20 different data points with 20 different data values, and I tried to plot a scatter plot, and you can see that the trend or the chart is giving me a correlation between the x-axis, x value, and the y value in such a way that there is no correlation at all, which means r is equal to 0. Right. R is basically the Pearson's correlation coefficient, which we will study in the subsequent slides. So R is equal to 0 here, which essentially means that there is no correlation between x and y variable. Now the question which comes in our mind is, why is this not a scatter plot, or it is not the correct way to plot or analyze it? Of course, you have two different variables. One is serial number and the other one is value, and you have plotted a graph and you are getting a plot, right? You are getting a scatter plot, but this is not actually the scatter plot. Why? Because serial number is basically the index value from 1 to 20 in a serial order, and for each of these serial order you have a value against it. So the values are still random values, but the serial number is an ordered value, which is just an index value, right? You have an index in your copy index, your notebook. That is how we have just taken the index numbers or a serial number, and hence you cannot create any correlation or any relation between the variable serial number and the variable value. Though you can always go ahead and create a scatter plot, but this is really not the correct way, because you will never get any correlation between these two variables. That is why I am saying that this is not a scatter plot, although you can always plot it, but this is not a scatter plot, because you will not be able to justify what is the relation between the variable 1 and variable 2, which is represented in the x-axis and the y-axis. So I have taken another value point. Now you can see x as an independent variable and y is a dependent variable, right? And the formula what I have taken here is the relationship between the x and y is that x, when multiplied by 0.2, which is a slope, and added with 1.1, which is a constant noise or a constant, it gives the value of y. So y is a dependent variable which is dependent on the value x, right? And hence for each of the values x, you will have a value y. So if value x is 0.38, you need to put it into y is equal to 0.2 into 0.38 plus 1.1, which will give you 1.18. In the second row, the x value is 0.98 and you have to calculate the value y, and the value of y is calculated as 0.2 into 0.98 plus 1.1, which will give you 1.30, and so on and so forth. You are getting so many different values of y which are dependent on different values of x, and it is calculated by the straight line equation, which is y is equal to 0.2 into x plus 1.1. I hope this is clear. Now when we try to plot this, it gives me a straight line equation, wherein you can see that the scatter plot, and r square is equal to 1 and y is equal to 0.2x plus 1.1. Hence Pearson's correlation coefficient here is 1, right? So I'll give you the different ways in which we can see different values of R, which is the Pearson's correlation coefficient. But here R is equal to 1, which means that it is a perfect correlation between the X and Y. And it is a positive correlation. Now, what is positive correlation? What is negative correlation? What is weak correlation? What is weak positive correlation? What is weak negative correlation? What is no correlation? I'll get to these points in the subsequent slide. But for this particular topic, as of now, you just need to understand that this is how the scatter plot is created you can create in the form of Excel as well. Now, coming to the definition, a scatter plot is a type of graph which is used to represent the relationship between two variables in a data set. And these two variables are independent and dependent variables. Variables are also called columns, right? So there are two columns in a data set. One is independent column and the other one is dependent column. The scatter plot is also called scattergram, scatter chart, scatter graph, etc. Now it displays data points on the two-dimensional plane, which is X and Y. So two-dimensional plane is X and Y axis, and you have X axis and Y axis wherein the independent and dependent variables are plotted. What is Pearson's correlation coefficient? So Pearson actually designed or devised one correlation coefficient, and it shows the correlation between the two variables X and Y. And the value of the Pearson's correlation coefficient varies from -1 to +1. Now let us look at the different ways in which we can really look into the scatter plot and analyze it. In the center, you can see no correlation because there is really no correlation between the data points, and R is equal to 0. Okay. Now, in the perfect positive correlation, I'm looking at the R is equal to 1. You can see that all the data points are strictly lying on the straight line, and that is why it is perfect positive correlation. Perfect positive correlation means that if there is a change in the value of X, there will be a same ratio or same proportional change in the value of Y as well. So that is your perfect positive correlation. Highly positive correlation, whereas R is equal to 0.8, you can still see that it is lying on the, not lying exactly on the straight line, but there is certain deviations here and there, but you see that they are still forming a straight line, wherein the R is equal to 0.8. A low positive correlation, you can see that is still the variation or the range has actually increased between the data points, but they are still forming a straight line and moving in a positive direction, and that is why it is called positive correlation. In the negative correlation, you can see that the slope has a negative slope. The straight line has a negative slope, and that is why R is equal to -0.3 is a low negative correlation. The R is equal to -0.8 is highly negative correlation, and R is equal to -1 is perfect negative correlation. What does negative correlation means is that if there is a change in the value of X, there will be a change in the value of Y as well, but in the opposite direction. Like say for example, stock market. If there are two different stocks, stock X and stock Y, if the value of stock X increases, the value of stock Y decreases. So these two stocks X and Y are negatively correlated. And if the value of stock X increases in a proportion with increase in the value of stock Y, then we can say that stock X and stock Y are positive correlated. So that is how we can look at the different values of R and talk about the correlation examples. I hope this is clear, and this is all about the scatter plot or scatter chart. Thank you.